Let me give you an example of the relationship between Q and K. And what we can say here is we've got a reaction and we've been given a bunch of concentrations. At the present, we don't know whether the reaction is at equilibrium or not. All we know is that these are the concentrations of the reactants and products at a certain given time. The temperature here is not really meaningful. It's going to be at a constant temperature, and that will ensure that the value of K will remain constant as well. So the value of the actual temperature is not important, but the value of K will become important in a minute. Now, K is big K, of course, so we're talking about equilibrium constant. So we're given the equilibrium constant, all these different values. Now what we're going to do is we're going to figure out Q. Now Q is going to have the same expression as K. It's going to be SO3 squared, SO3 to the power of 2, over SO2 squared times O2. So we've got these to the power of their coefficients. Now what we have to do is just plug in the values, and these are the values we're given. So SO2 is 5.0 times 10 to the negative 3, that goes in there, and that's squared. And you've got O2 is 1.9 times 10 to the negative 3, and then SO3 is 6.9 times 10 to the negative 3, and that's squared as well. So we just go ahead and calculate all those, and it turns out that Q is going to come to a value of 1002. Now we usually don't worry about units when we're talking about Q and K. They're not particularly meaningful, but we do worry about the numerical values. In this case, we can see that the value of Q is 1002, which is different to the value of K. So that's proof enough that we're not at equilibrium. So Q does not equal K, so we know we're not at equilibrium. But what we can do, as I described in the earlier mini lecture, is that we can figure out which way the reaction is going to go based on the comparison of Q to K. So it turns out that since the reaction has a Q value of greater than K, 1002 versus 279, then what's going to happen is the reaction will want to lower its value of Q. And it will do so by decreasing product, or if you'd like, increasing reactant. So what we can do is by increasing the amount of SO2 and O2, that is by moving to the reactant, we can lower the value of Q and it will get closer to K. In so doing, in forming these products, in forming the reactants, the amount of product will also decrease, and that will also allow Q to become closer to K as well. So we'll be increasing reactants and decreasing products, and that'll bring Q closer to K. So the wording for that, the reaction will tend towards a lower Q by decreasing product, or if you'd like, by increasing reactant.